All right, so thank you for having us here today. We want to make this presentation as interactive as possible, so ask us questions. You can ask almost anything. We'll either make up an answer if we don't know. You could, ask us what our backgrounds are, how we got here, and then we have a couple slides to go through, and we're going to talk about our marketing and coding equipment. So to introduce everyone in the room, I am Scott Duddy. I am the managing director of this group. David?
David Podolsky. I'm the director of engineering and technical services.
And then in the back is.
I'm Jennifer. I'm communications and events.
Okay. So we've done these presentations before with universities. We're going to walk through kind of who Matthews Marketing Systems is, Matthews International. Does anyone know who we are? Did you do any pre-work before the class? They're all failed for the day. All right, so we're going to talk about who we are. David is going to walk you through all the technology, how it's used. As you can see from some of the samples we have up here, our product touches basically anything you touch, right? From boxes to soap to Cheerios. And then, feel free to stop us in the middle of the presentation to ask us questions, and we'll go from there. All right, sound good? All right, so before I go through here, two things. I tend to speak fast, so tell me to slow down. And I had a lot of coffee this morning, so I'm amped up especially. All right. So who is Matthews? We're a global company, over 10,000 employees, $1.6 billion in revenue. We're one of those companies you probably have never heard of, right? By the lack of hands, definitely didn't hear that. So we have a global presence. We're somewhat evenly split between Asia, Europe, and the Americas. We are probably heavier in the Americas, predominantly in the US, and you'll understand why here in a second. All right, so Matthews started in 1850. It is the longest running company in Pittsburgh, Pennsylvania. Okay, so for those that enjoy Heinz ketchup, Matthews has a longer run as being manufacturing in Pittsburgh, Pennsylvania. Matthews, actually started by John Matthews, started with engraving equipment. Okay, so stamping on wood crates to working with the military. That's where Matthews got started. So in theory, in 1850, Matthews started as a marketing and coding company. Okay, we're a publicly owned company. We are made up of 3 pillars in our organization, and I'll let you know right now, they're nothing alike. All right, so we'll talk about those. Our first pillar is called SGK Brand Solutions. By looking at this presentation, does anyone have any idea what this group does? I need one guess. Please don't make me pick on you. Any guesses? Thank you. All right, so what they do is they really talk about that consumer feel when you walk into a store. So when you walk into that Apple store, how does it make you feel? How does the banners, how does product placement, how does that work? They're the ones who go behind it. So Apple, Coca-Cola, Nike, we work a lot in Nike stores. So when there's a big Air Jordan release, the Nike stores, that's SGK behind it on what does that look and feel, and what does that really Nike symbol mean to the customer. This was an acquisition we made in 2013. Very large acquisition, a lot of different brands, but it's predominantly known as SGK. Okay. All right, next one is memorialization. What does that mean? Yeah, so we make caskets. All right. Again, I told you this was nothing alike. So we were just talking about Apple and Nike. Now we're talking about caskets. So how did Matthews get involved in this? Well, I talked to you about branding, and they start making bronze plaques, right? And it was placards put onto equipment, to military tanks, things like that, right? Well, does everyone recognize that? And for those sports fans, Cooperstown, right? Baseball, all the bronze statues when you go in the Hall of Fame. That's Matthews. Okay, so kind of cool. But we also make caskets. We make cremation ovens. Again, nothing related to Apple, Nike, but very different. So one quick story on the cremation ovens. We are into, obviously, human cremation, pet cremation, and we're calling it environmental solutions. So when you go to a country that makes a sacrifice, okay, so in the Middle East, they tend to have religious holidays around sacrificing animals, okay? Well, they go through this, they have to do something with the carcasses. So besides just burning them and causing environmental issues, they now use cremation ovens. It's a very different use, but it's also very different. So basically, so far I've told you, we make the Nike symbol. Pretty cool. We make really big pizza ovens, right? And now, for the most exciting thing, industrial automation. That is our group, okay? What is industrial automation? It's broken down to 3 groups. So we're going to talk a lot about product identification. But there's a group here in the middle that I guarantee each of you are a consumer of, and you just don't know it, called automation solutions. And then we have OEM solutions over here. So let's talk about them. So what is automation solutions? So we have 2 groups under here. Who orders from Amazon? There we go. Now we're awake. All right, so Amazon. Does anyone ever wonder how that package arrives in 2 days? And when it doesn't, you're not happy, right? You paid for that prime shipping. Well, what this group does is they design the software that goes behind how to pick and ship it. All right, so if you think of a big distribution center, you have this big wall, and you can kind of see it in this photo right here. They have to know what to pick. The old style of picking in a small building would have been, I got a piece of paper, I'm going to run and pick it. What they do is, I now am responsible for this whole area, and there's lights, and it just tells me what I need to pick. So there's no thinking. It brings it up to like a 99.9% picking accuracy, so you don't get the wrong, whatever you order from Amazon, to your door. So I now picked it. It now has to go to shipping. So it gets on a conveyor, runs that box down the line. Our software is running that conveyor to tell it where to go, because when you go to major distribution center, there's splits. That box can go a lot of different directions, right? So now there's a putting. So you put it away, or you put it ready to ship. Again, lighting system. So big companies that, when we all shop e-commerce, Target, Kohl's, Amazon, they use these systems to make sure they have accurate picking in the most effective way. The next thing that is part of this, and it's called OEM solutions, one of our acquisitions was robotics. So besides having the person push the cart down the aisle, now you have automated vehicles that move that box to where it needs to go. Okay, so very different. Again, nothing to do with caskets, but in a casket manufacturing plant, you could easily use this. All right, so Matthews marking systems. So we make industrial printers and ink that do anything from a little Best By date to flammables to marking on lumber, corrugated materials. We have a lot of different technology to do this. Kind of what makes us unique is global presence. So we have customers all over the world that use our products. All right. We manufacture and develop our own ink. What's key for us in that is that we can, if someone wants to mark on this and we've never marked it before, and there's something really special about this corrugated material, we will develop an ink so it sticks to it, dries within a second, whatever the case may be. Right? We started in the US, we've expanded, and we have one of the best softwares out there that David's going to talk you through. Okay? So that software integrates to everything on that conveyor line, to what that mark is supposed to look like, all done through our software. Okay? So here's some of the industries we're heavy in. Our main industry right now is building products, so lumber. So I saw it here, the Uber engineered, right? We're also into all our CPG type customers here. We also do, and David actually leads the group, is custom. So if you have something very unique on your line, how your printer has to be mounted, or maybe it needs to move around as it prints, this group actually takes care of that. Or you need a software change. We have a group that takes care of that. So basically, there is no job that we can not do. This is actually it's growing. We know that there's always recalls on food, to tires, to whatever the case may be. So marking and coding is a growing industry. Globally, does anyone want to take a guess? I told you this was interactive. I've been talking a lot already. Does anyone want to take a guess on how big this industry is, marking and coding? What do you think? How big do you think it is? I told you our company is $1.6 billion. No. So it's $4 billion, but at least you got a guess. That was good. All right, so it's about a $4 billion industry that's growing faster than the economy. All right, so the reason is this stuff up here is becoming even more important, right? When there's a recall, Toyota makes a recall on an airbag. That airbag has a little marking on it. It's becoming extremely important anymore. So now I'm going to hand the presentation over to David. He's going to talk to you about different equipment. Please ask questions.
Okay, again, my name is David Klodowski. I have the engineering team and the ink development team. And so we're going to go through the different packages that we mark on. Part of the way to think about what we do, right, is that when you look at a Cheerios box, right, and there's all the graphics and packaging that goes with that, that's what I call static packaging, right? So that packaging will stay the same for a period of time until somebody in marketing decides that needs to change, right? And we want to change our branding and we want to do something different. Static packaging is all the bright colors that you see on all of this stuff. What our particular products do is the variable marking. And so when I mean variable marking, we are, to Scott's points, we're putting on the best by date, the use by date, the made by date. We are putting on data that is dynamic, that has to be applied at the time that that product is either being manufactured or being filled, right? And so you can have this box of Cheerios, and there can be a couple million of these boxes sitting in a warehouse, made and ready to go, right? As they start to fill them, that's when our technology takes over, and we now have to print on every one of those boxes. And it's that variable data, which may be, again, a timestamp, it's a lot number, it's a lot of stuff that's used for traceability of products. And so that's what our particular products are made to do. And so as you see these different things up here, right, it's this kind of stuff that we're marking. And that is all done at the time of manufacturing. And that creates a lot of fun issues to resolve, right? Manufacturing a box and having the box go through a printer is relatively easy. When you think about printing at home and you have your lovely little HP printer and you send your 10-page paper that you had to write to that printer, it prints that out. That's relatively easy to do. And the reason I say it's easy to do is because that printer controls that paper, so that printer knows where that paper is at all times. That ink is easy. That ink is just a water-based black dye ink, and it goes onto a piece of paper and the paper absorbs it and you don't have to worry about anything. It becomes very, very easy to do. When you start thinking about, I need to mark on this package, which is plastic, well, I can't use water-based ink because water will run right off of that. So I have to come up with something else that's going to print onto that. But I also have to realize that this is on a production line, and these are flying past at 500 feet a minute. And they're moving when they're flying. So I have to track that movement, and I have to know where every one of these are so I can put that mark that I have to put on here in the same spot every time, all the time. So the challenges of doing the type of printing and coding that we do are really around the material handling and everything that goes on in the different systems. It also has to do with all the different substrates, right? And so printing on cardboard versus printing on plastic versus printing on glass versus printing on wood versus printing on steel all drives many different behaviors. A lot of that is driven around the different inks that we use. So corrugated, and so you guys have a big corrugated program. One of our funner things to print on. And as we go through our technologies, the thing that will typically print on corrugated for us will be a T-series head. That's that one there. It's a, that gives you a 4-inch high mark, and it will print stuff like that, right? Printing on corrugated has gone from just printing words and letters now onto barcodes, and then we get up into where we're doing the full graphics on cardboard anymore. So the printing on our end has also started to run into some of the printing of pretty boxes. And so where a warehouse can have, instead of having to have all pre-printed corrugated boxes, they can now just send it down the line, and our printer can print all the branding and everything else that they want on that box at the time. And now they can just buy one blank box. Saves a lot of time, a lot of money, a lot of warehouse space. And that really is the tertiary packaging is the packaging after. So we've put it into a lovely Cheerios box, and then we've put that Cheerios box into a lovely corrugated box, and then we're going to put that on a big pallet. And that pallet's going to be wrapped in plastic, and there has to be stuff marked on there because that's going to be shipped. A lot of times that's marked with a label. Labels are problematic because labels come off all the time. Once the label comes off, what do you do? So we've talked about sort of what we do. Next we'll talk about our products, right? And so any marking company, and we're not the only ones out there, obviously, there's a bunch of them out there. Any marking company will have a bunch of different print technologies, which is what we have, and they'll have a controller that controls them. Our biggest competitive advantage is that our controller is a software-based controller, right? And so this is a touch, you know, it's a PC, it's a touch screen PC that we buy, right? We don't actually manufacture that piece. It's a piece of equipment that we buy. We load our software onto it, and that's where the fun begins. So we have a Linux-based software that we load onto that thing, and that is our print controller. Most companies have a controller that is software and hardware specific, so it has hardware in it that's used to render images. Ours doesn't. We do it all on software, so we can change it really easy, and that gives us a big advantage. The different technologies that we're going to talk about. So the first one up there is L series. That's this print head. L series, it's just our name, thermal inkjet. Thermal inkjet, you all should be familiar with. It's your lovely home printer. It's the cartridges that you use in the home printer, right? So that's what thermal inkjet is. Thermal inkjet, we have cartridges that we sell that are single use, and we also have it so that you can do it in a bulk system, which has a cartridge that will have a tube coming out of it that you can refill that cartridge from a liter bag or a liter bottle of ink and continue to print. The advantages of L series are high resolution, right? So L series is 300 DPI, so you can get very fine barcodes, very fine graphics, very small characters that you can get fine detail in. So that becomes a big issue, especially when you're printing a very small space and you have to have a highly legible date code or barcode. An L series will do it. The next is the T series. That's this printer. The T series is a piezo printer, right? And so this is a 4-inch high. We also sell a 2-inch high version of a piezo printer. And piezo is just a piezo crystal, and a piezo crystal vibrating is what's spitting that ink out. On the thermal inkjet, how a thermal inkjet works, when thermal inkjets first came out, way before all you guys, they were called bubble jets. And the reason they were called bubble jets is because all you do with a thermal inkjet is you heat up the ink with a resistor. It forms a bubble, spits out a drop of ink. And so they started off calling them bubble jets. Everyone thought that was a silly name, so they changed it over to thermal inkjet. But that's how a thermal inkjet printer works. It basically heats the ink that spits out a drop. Piezo is crystal technology where you're vibrating that crystal with a frequency, and that vibration kicks out a drop of ink through a valve. Laser. So we have CO2 lasers and fiber lasers. This is the one that we're showing here is a CO2 laser. So there's a CO2 tube inside here. That's what generates your laser beam through the lenses. CO2 is usually used for a lot of plastics and a lot of glass. And then we also have a fiber laser. A fiber laser is used to mark on metal, and it can also be used depending on the plastics, right? And then we talked about the engineered solutions piece, where we can take any of this stuff and put it into a system for you. So our universal controller, or again, we're showing one version of it, but this is where you create a message, send that message down. Built into the controller are all different kind of barcode formats. Probably one of the biggest things that we do anymore is barcodes. Everybody wants to have a barcode. Everybody likes to be able to track their product very simply and quickly. We also see a lot more QR codes that want to go on products so that people can scan them and go right to a website. And so all of that stuff is built into our controller and allows you to print whatever format barcode you want, call up that format, type in whatever characters you need to type into that. You can make it sequential so it keeps rounding up and keeps going. Again, just the overview of our different controllers. So we sell several different versions, and what you'll see here is and the one we're showing here, the big one here, is an IP65 controller. And so IP65, does anybody know what IP65 means? Does anybody know what an IP rating is at all? So IP65, IP ratings are how products will react in a production environment, right? And so IP65 means that that controller can be washed down. So when you're in an environment, especially when you're in an environment that's making food, something that a consumer is going to ingest, a lot of those production lines are washed down when they want to change over, right? And so you have to have equipment out there that's going to be marking on that packaging. It has to be able to be washed down. And then you see in there's a couple other controllers that are enclosed controllers. Those enclosed controllers are for very dusty environments. And so as we talk through the products, right, we do a lot of packaging products. We also do a lot of building products, right? And so Uber, who's not far from here, is one of our customers. Uber does engineered woods, right? And so we do a lot of engineered wood products. And in those particular environments, it's all about dust. There's a lot of dust all over the place. For doing those type of markings, we use our V-Series head, which is a large character marking head. Up there, again, 3 different versions of the controller. A small version we call the light then is enclosed, then we have a standard, and then we have the standard is enclosed, and both of these enclosures are mostly for dust, and then you go to the one we're showing here, which is the IP65 rated controller. So when we talk about packaging, probably our biggest product line that goes into packaging is the L series. We sell the L series in a single head, right? And so cartridges you buy are 1/2 inch high. So every print head that you buy, that little cartridge is a 1/2 inch high. This particular module shows those two cartridges together to give you 1 inch high. We also sell a version that'll give you 4 cartridges together that'll give you a 2 inch high, and you can continue to stack them to make them as high as you want. The biggest advantages, again, of L series are high resolution, right? And so 300 DPI can give you a very, very crisp character in a small area. So as packaging is being designed, one of the things that has to be considered is we have to add this barcode to it. We have to add this date code to it. We have to add this lot code to it. Where do you do that on that package, right? And so a lot of times you'll see in packaging designs, there'll be a knockout that's put into that packaging design so that that gets printed on. Right on this particular one, we're doing it right on the blue, right? That blue with the white coming through, what do you think we did that with? No one's got a guess? That's a nice, very crisp mark. And what that is done with, that was done with a laser. And how you know it's done with a laser is because it's very crisp. And when you look at it, all we did was what is called ablating. We took the blue off. Underneath it is the white. So it's just them characters across the top on the blue. So that wasn't pre-printed. That was done at the time that box was filled. That box would go past a laser marking head, and the laser would take the blue off, and the white behind it would show through, and that's how you form the characters.
I think there was a question.
Yeah.
You mentioned before how y'all get machines that print the boxes in-house, so companies no longer have to buy pre-printed boxes.
Yep.
How long does it take to print the graphics on those regular style boxes like the Cheerios boxes?
So you wouldn't be able to do a full Cheerios box, right? We're not to that technology yet, but I don't know if we have a picture that I could show. So when you get to something more like this, where you're printing the graphics on the outside of a corrugated box, and then we can also do that in colors, right? And so the T-Series printhead, as we go to this, can go quite fast. So you can be up around 150, 200 feet a minute of boxes going past, right? And so always remember, when you're talking about speeds, you're talking about the speed of the conveyor, which is one thing, but then you also have to talk about the spacing of the product, right? What's the gap between products? How long, how tall are you printing, are all the things that make a difference in those calculations. But yes, on lines, we haven't, it's very rare that we've run into a line that we can't handle the speeds. And there's different things you can do with the printers, right? So you can sort of turn down their density a little bit, so the mark may not be as bright, may not be as red or black, but in doing that, you're allowed to, you can increase your speed, right? And so you can do that on the T-Series, you can do that on the L-Series printers. And the same with the laser. The laser, one of the things, everybody's got a laser, and it's all interesting. All of our competitors have all of these same types of products. The thing that differentiates us is, number one, is the controller and the speed of our controller, right? So our controller runs really fast, right? And so we just stream Ethernet down to our print heads, and that's how fast it goes. And then the laser has the fastest marking head in the industry, right? Which is really the mirrors. Inside a laser, there's a beam that comes through, and then there's mirrors that direct that beam to move to form all those characters, right? And in any laser, it's just one beam. So it's writing that whole thing you see on there. And and we could probably do that in, I don't know, probably about 0.2 seconds, if not faster. And it's the speed of those mirrors that's making that marking move on the package. Go back up to the L series. And so L series becomes a very important product for us because, again, it's high resolution and it's small character, right? So you can put the small date codes, lot codes, Best Buy codes. The other thing to worry about when you're doing all this stuff is, what ink are you going to use? Again, when it comes to plastic packaging, more than likely you're going to be in a solvent-based ink. And now solvent-based inks make things very exciting, right? Because now we're using solvents that are like MEK, which is methylethyl ketone. We're using ethyl acetate. We're using alcohols. We're using acetone. The reason those are all used is because they dry extremely fast. And so when you're doing a Cheerios box with a laser, all you have to worry about is the box in position and can I print on it? Yep, and they keep going. When you start printing with ink, you have to worry about everything that happens to that package immediately after that package gets marked. Because if that package now goes and a roller on the production line goes right across that mark, that ink needs to be dry so that it doesn't smudge. Well, in order for it to be dry, it's going to be a fast dry solvent. So fast dry solvents are great because they'll dry in under 2 seconds and everything can go on, but they can be very nasty. They're categorized as dangerous goods, so shipping them around the country poses all kinds of problems. but it also poses problems in manufacturing plants because they have to deal with the waste and the spills and everything that goes along with those particular inks. So depending on what you're marking on makes a big difference to what you can actually use to mark with. And so the other thing that needs to be considered in all of these designs when you're designing up the packaging is where are you going to put that variable data that you have to put, right? And when we say have to put, you know, to Scott's point, our market's growing. Our market's growing because of government regulation. Our market's growing because of recalls all the time, right? And so, especially in the food industry, where everything needs to be tracked from the beginning to the end, that is usually our equipment that is marking those things on there because it has to happen at the time of either manufacturing or processing that happens on those particular products. So the L series, the thermal inkjet is used a lot for the plastic packaging as well as corrugated. It is a good small character printer, right? Small character, high resolution. Yes?
So you said it prints 300 dpi. What's like the industry average, like standard typically?
So typically a lot of the packaging that you'll see uses a CIJ mark, which is a continuous inkjet mark, and it's usually under 100 dpi, right? And so those are the ones that, well, when you look on a bottle, right? So if you look on your Coke or your Pepsi bottle or your milk can or something, and you can see the characters marked and you can really see the dots that make up those characters, that's done with continuous inkjet, CIJ. When you cannot see those dots, that's when it's done with thermal inkjet, right? And that's the difference. It just gives you a much more continuous character that is formed, right? You don't see the drops as much with a thermal inkjet. You will barely be able to see the drops with a thermal inkjet.
You have to remember when you use the drops, you just have to be able to read them. Right? So the resolution isn't as critical as you can see with drawing. Right?
And so this on corrugated is done with, I'm trying to remember. I think it's this is a 4-inch high mark. It's done with 8 L series pens. So this is thermal inkjet, and when you look at that, you really can't see the drops on that particular piece of corrugated. The next one, and the one we see on boxes the most that's used on corrugated, is our T series, right? And so, you know, the poster over here is a great example of doing some amount of branding as well as some amount of information that has to go onto the box due to regulations. And again, up here, some amount of branding that gets done. That's a piezo head. And the piezo heads have glycol-based inks. And those inks are made to really absorb into the corrugated more than they are actually to dry. They do dry, but it's the absorption into the corrugated. And then they're also formulated, we have 2 versions. One's called VersaCode and one's called AccuCode and AccuScan and VersaCode. And they're there to make good, solid barcodes, right? And so on corrugated, a lot of barcoding, either 1D or 2D barcodes are applied. And so the inks are formulated specifically for that. They give you crisp lines. The T series is native is 64 DPI, but we take those 64 drops coming out of the channels and we multiply them by 3, so we can end up having a vertical of 192 DPI. And again, the T series is mainly made for corrugated. The inks on the T series cannot go on plastic packaging. They can only go on either the white cardboard, brown corrugated. They can go on kraft sometimes also. And so we do a lot of, you'll see that mark would also be on that that very similar Cheerios box where if they wanted to use ink. 8000 print head. This is our more of our building products print head. That's this guy over here. It has the lowest resolution. It's on the nozzles are on 4mm spacing, right? And so you only have about 6 DPI. But it is heavily used in building products. So again, we do a lot in wood and lumber, corrugated. We do some in corrugated too. We actually do tray packs with the L series head, but mostly engineered wood, steel, drywall. Almost anything you go to a Home Depot and see that you're going to build with, a piece of wood, any of the 2x4s, any of the lumber that's in there, any of the drywall that's in there, any of the insulation that's in there, probably went through one of our print heads and is printing the data that's on those particular products. In the packaging world, we do a lot with the V series on tray packs. So tray packs are the small pack around the bottom of a can of Coke, you know, a case of Coke, case of Pepsi. We have a lot of inks on the V series side that can print right onto the cardboard, but it can also print onto the plastic that goes around the cardboard, right? And so there's a lot of utilization of that product when it comes to the tertiary packaging, when you're packaging around a bunch of boxes that are put together. Laser. So again, laser is used in the packaging world quite a bit. Why would you pick a laser over an inkjet, or why would you pick an inkjet over a laser? Has anybody got any ideas? Substrate's one factor for sure. Any other factors? So the laser is quite a bit more expensive than any of the technologies we've talked about, on the magnitude of 10x more expensive, right? So when you're buying a laser, you're going to get the controller, and then you're going to get the marking head, right? And so the things with lasers are, because they're big, a lot of times they're hard to fit onto a packaging line, and then they're more expensive. What's the advantage of a laser over an inkjet system? Be a sharper image. Someone else said what? No ink. Right? So think about your home printer. Think about the printer you bought for your dorm room, whatever. How much you pay for that printer? $100, $120, $130? How much have you paid for the ink? Too much. And that's the primary difference, right? So an inkjet system will have a lower capital cost to buy it and put it in, but it's going to have its ongoing ink costs, right? And so every year you use that, right? And if you look at that lovely little home printer you got, probably within the first year you spent more on ink than you did on the printer, right? Those cartridges can be quite expensive. With a laser, it's going to be a lot of upfront costs, but I don't have to buy any consumables. I don't have to buy any ink. I don't have to worry about ink spilling. I don't have to worry about all the stuff that may come, especially if you're using a solvent-based ink, right? And so those are the primary things, but there's lasers can only mark on so many substrates, right? They don't mark on all the substrates that you can actually mark with ink. You know, a lot of times the laser has to either ablate something, like you see on that Cheerios box, right? So there's a layer, when that packaging design was done, there's a layer of white underneath there, and then there's a layer of blue on top of that. And then we took the layer of blue off and the white came through. So that has to be thought about in the packaging and design if you're going to use a laser. Where if it's just on a yellow and I have black ink, I can just print on that yellow and I can be done with it, right? And so there's a lot of things that have to be considered when you're changing from an inkjet to a laser. And again, a laser cannot mark on everything. One of the things that lasers are good at marking on are glass, right? And so you start to see the industry, you know, on your wine bottles and on your beer bottles and on your alcohol bottles, which, you know, I'm sure none of you guys are aware of or have ever seen. That'll come later in your life. But those are primarily changing over to laser marking. And the biggest reason is they get rid of the ongoing ink costs, plus they get rid of any of the hazardous substances that ink comes with in their packaging areas. And so that's another big concern for our customers. Yep.
The inks that are being ablated, are they formulated for that purpose, or are they just?
No, they don't have to be formulated for that purpose, right? So you can use almost any ink that you want on the packaging as long as there's an ink under a color underneath it, right? So that is just the white and the blue that they had in their Calo palette, and then we can adjust the laser so that it only takes off the blue and doesn't take off the white.
Is the white the substrate, or is that another layer?
That's another layer of ink. Any other questions? Lasers are cool. There is, and what you'll see is like on corrugated, right? You can't really use a laser because a laser, you can't get contrast, right? So the laser can hit it and mark it, but you can't really see it, right? When you turn it like that. There are substances that you can put onto corrugated, right? That will allow that to show up. But then as you start doing the ROI on, do I buy a laser, and now I want to be able to mark on those boxes, but now I got to add this to the box, and how much cost is that added to the box, and should I just do that, or should I just stay with inkjet? It all gets to be a very, very interesting calculation on what's the best way to go. So we primarily talked about fiber laser or CO2 lasers, which are the biggest in the marking products field, CO2s. There's also fiber lasers. Fiber lasers you'll see a lot of times are for metal marking. So when you, you know, beer cans, pop cans, any kind of can, as well as most metals that the fiber lasers will mark on. So again, this just goes through our different print technologies. And you know, we had the question before about the speed, right? And so different speeds, right, which are a consideration of what technology you'll pick. How fast is your production line running, right? Lasers are nice and fast, which is great because if you've ever been into a plant, and I've been into a bunch of them, but if you go into a plant of a spirits maker or a beer manufacturer, those lines are running very, very fast. And it's quite interesting to see how fast they run. Every can has to be marked. Every bottle has to be marked. None of them can be missed. And so, again, it becomes a challenge for our particular kind of printing and what we do, right? And so when we talk about the fact that you can't miss any product coming down the line, one of the things you'll see with any of our print technologies, we always offer, it's an encoder. What's the encoder to do? All an encoder is doing is tracking the speed of that production line. So it knows how fast that production line's going, so we know when to print. And then we also, one version, it's called a photocell. Anything that triggers, right? And so as bottles are coming by, I got to know a bottle came, bottle came, bottle came, bottle came. So we have to have something that triggers the printer to tell it to print, and then it has to print instantaneously. We have to have something that tells it how fast that bottle is moving, because as we're printing, the bottle's moving, so we have to adjust to the speed of that bottle, right? And so for almost every marking system that we sell, we also sell an encoder and a trigger. And so those go into the different production lines that are being run through all of our various products. And so I hope when you were talking before about speeds, these are the different speeds that we can run. And again, we can also increase those speeds if we change our density and how dark we're printing. That's all we got.
So we got about, I think, 6 or so minutes left for the class. Well, this is your time to ask us questions. Anything. I know we threw a lot of information at you. So, ask us anything from different industries that we're in, to our backgrounds, whatever you guys are.
So in the future, the concept is we can mark on anything, we can mark at a variety of pretty fast speeds. When do we think the technology will be at a place where all we have to do is leverage stock containers and add full rapid spread?
Yeah, and so that is, and so we do some of that now at a lower level, and it's, the industry is obviously building that way, and that's really sort of the, what you would call digital printing, right? And it's how do you take, common stock and be able to print and fill and go. And I think there'll be some industries that get there, there'll be others that never will. It's probably going to be, I would say, we're probably still 10 to 15 years away from it being readily picked up by the industry, right? It's, the capital costs are big to be able to do that, right? And then how do you do that with a bunch of different colors? People want to maintain their brand, right? So Bounce wants to have that big orange that they're known for, right? But then you got to have the white and every other color that comes with that. So that makes the complexity of those machines very, very high. And anytime there's high complexity, there's high cost. And so as that complexity gets more commoditized and the price comes down, then we'll start to see, I think, that being taken up more and more. There are companies out there now that are selling it, right? You can buy machines that are big, big machines that cost a lot of money. And so it's starting to happen. It's going to take time, right? It's just like any other technology trend. It has to go through its process to make everything smaller, faster, cheaper, and eventually it gets taken up by the masses. But I still think we're a ways away from that happening, but it's coming, for sure. Yep.
You guys involved in RFID technology?
Is that?
As far as traceability goes, are you guys involved in RFID technology?
We don't sell our IFD technology. We will take advantage of it, right? So we're as we go through on our particular products, right, and some of these ink systems where we want to make sure that people are using our inks, we'll be putting our RFID tags on all of our ink bottles, right? So that's a way of us taking advantage of that particular technology. But as far as us selling it, no, it's not in our future.
That's strictly for packaging applications?
Yeah, we do direct mail, so the L series head is on direct mailing systems. We have, in our software, we have a license that's an upgrade package for high-speed mailing, right? So you can do a couple million row database in our controller and print out at a high speed, so yeah. And actually, one of the divisions in the OEM side is mailing software. It helps do that. So we have synergies with those guys. Any other questions? So you guys designing all these packages, right? Okay. So when you're designing those packages, remember us two stooges that were up here. Make sure you put a spot on there so that you can put your late code and your barcode and your non code. Trust me, as it goes, it's going to get worse. More and more government regulation will put more and more information on there. And that's going to become a very big piece of packaging design. Where do I put that? How do I put that to make it easy and cheap to get it done?
So we will still be meeting for labs this week.